of some blockchain and how the blockchain works. So there's this really cool thing over here at superdatascience.com that has a really neat downloadable code set that you can actually go ahead and bring up a blockchain demo and how it works. So if you're interested in learning how to hash something, you could actually just go ahead and poke some data in there and to say, here you go, here's some course highlights for you, and let's go ahead and let's hash it out. And we'll automatically redo that hash for you. You can kind of watch that hash. So if we take out these lines here, that hash will change. And again, it's just that idea of that all of these words equals this particular hash value. And again, this is a non-editable block. You can't edit that. But as you go ahead and you take things out, a blank box has this. And again, as you add data to it, that hash value will always change. It should be impossible mathematically, or at least mathematically improbable, to change or have two different files have the same hash value. So hashing is really kind of cool. It's just your standard 256 SHA hash. And this is just a way of signing a piece of paper, right? It just basically says that this data has not been tampered with or anything else. So when you get into the block though, right, and you start going into blockchain, you'll notice that this hash value here is still on this. You have a nonce, you have your block number 1, so this would be considered the genesis block for what we're doing. And you can go ahead, throw in your text, and then click on mine, and it will implement it and go ahead and say, okay, now your block 1 has a different nonce, has a different data set, and this is the data that's inside of it, and the hash value changed. So you can actually go through and then change all this stuff out as much as you wanted to and see how things change. The nonce value changes and your hash value changes depending on how much data is actually in that block. So you can see how all these things kind of work together with each other in terms of that process. And again, these nonce values and hash values are going to change for everything that you put in there. Now the cool part is when you actually start blocking things together, right? So let's go ahead and let's put the same data in on all of these. And there's going to be 5 different blocks on this, right? And what you can do is you can go and take a look at the previous. This is our genesis block, so it has no hash value at all. It's all zeros. Block number 1, nonce value, and then we click on mine. And it will give you a hash value coming up here in a minute, 009. Now notice on 009326, you get the 009326 here as your previous. So they start chaining these things together. And as you mine these things through, you'll get block 2, different nonce values, right? Same data, but your previous hash is the same as your hash here. And then hash here is going to be the same as it is here for block 3. And then you go through and you mine it. The only thing that should change here are going to be nonce and your hash value, right? And then again, you go here, you'll see that those hash values match up now. Right, so we'll have to go and pull it. Ooh. So now we broke our blockchain, right? So this value, this hash value here, does not match that previous hash value before. So because of that, that means this data is now suspect and go, oh, wait a minute, there's something wrong here. Or else I just was really, really bad in my code and didn't do a thing right. Right? So there's something wrong here. Oh, and now it just updated. So could be go back and check. And that's where the whole idea of that peering model comes along, right? Is that, hey, this thing happened. All right, maybe your hash value didn't work out quite right. And then we're going to go ahead and we're going to update it and make sure that everything is concurrently good. And then you'll notice the hash value here for block 5 also decided to match out. And you can mine it out. And you could just keep on doing this all day long. And just keep on clicking on mine and going ahead and getting your boxes to go for where they wanted to go and do all the things that they wanted it to do. And that's how you do a blockchain, is that your nonce is going to change, your hash value should change, your previous value should match the box before it, so that you're kind of going from here to here to here to here to here, and so on and so forth as you kind of go through the process. The interesting part, though, is when you start getting into that distributed viewpoint, right, you'll have everything matching out on your original blocks in the different peers. So you would go here and put your data into here, and they would have to make sure that it worked. So what would happen if I put different data here, right? So we'll put in block 1 and we'll mine it. And we'll go and we'll get an answer here, and then my hash values will match here for block 2. All right, and we'll go there. And then this should match out to this one here, to just go ahead and do the thing here that you've got it. So your hash values match out and everything else. Now remember, we edited this one, right? So we'll have a different hash value here. Technically, this shouldn't work quite correctly, right? That we have a different issue here in terms of the data amounts. So this would automatically be suspect in peer C, and we would go back and we would check that, or it would automatically get negated throughout the process because peer 1, peer A and peer B have the full data, where peer C has a corrupted version of the data, and it would not work the way that we would want this whole blockchain to work. Then, of course, just simple tokens, right? When you kind of go through how do we move data from one person to another. So we have, Darcy moved $25 to Bingley and so on. And you just keep on adding on all these tokens, and the peers should match out. If the peers don't match out for some reason, then it would go ahead and either go and query the other peers to make sure that there was an issue, or if there wasn't an issue, you would have to go back. The network would automatically self-correct any of these things. That would be the problem, and that was part of the problem. That person that just lost the $14 million for the NFTs over at OpenSeas, they're actually able to get in here and change a bunch of the peering nodes to do that. And then, of course, just Coinbase, right? Coinbase would be the same thing. If we had $100 and we sent that off to Anders, we could just go ahead and mine that one out, and then Anders got another $10, or Anders sent Sophia $10, Anders sent Lucas, and then so on. And again, it's kind of that idea of here's how much money you've got in your Coinbase, and here's all the money that Anders is giving out to other people as you kind of go through it. So it's kind of neat. As long as all of these versions match each other in peer A, B, and C, everything is fine. If not, it should go back and self-correct, especially when it comes to money and tokens, as we kind of saw with peer C on this one. My little chunk of code here from Superdata Science didn't actually go back and match and validate A and B and C, but it would in the real world. So again, this is just really a neat way of figuring out how does that distributed blockchain actually work, and it's a nice little toy to go play with. So if you get the chance, go definitely check out that blockchain demo at Superdata Science. It's a neat little toy. They've got a cool Udemy course. Not that I'm plugging somebody else's stuff, but everybody deserves that little super hands up kind of thing. But again, it is just kind of neat that if you want to go and play with that blockchain, you kind of have that opportunity to go do it here. So definitely go check it out. It's a neat thing. It's at tools.superdatascience.com, and definitely check it out. Thanks much. Thanks for watching this lecture, and I'll see you in the next one. Take it easy.